to 4 different locations. You've taken 5 temperature readings at each location, and you're kind of interested in knowing that is one location hotter than another. Then it's quite a common experiment done, geography, bio, different subjects. So let's go ahead and find the means. Equals average, okay, and it's gonna choose sensibly. Okay, so it looks like 17, 17, 18, 17. Okay, it looks like possibly there's some evidence to say location C might be hotter. Let's go work out the standard deviations as well to look at the variability of your measurements. Equals ST standard dev, and I'm going to choose the standard deviation, drag and highlight. Let's drag across here. I already made sure that my data would be rounded to three decimal places. You can change the decimal places up here, and that looks good, right? So we could go ahead and draw maybe a little bar chart, not a bar chart, box and whiskers plot, that's right, to see the data. But what I'm going to show you now is how to use Data Classroom to bring all of this to life. Now, to use Data Classroom, we have to get the data from our spreadsheet, either Google Sheets or Excel, into Data Classroom. And we just need it to get into a simple form. So what we're going to have, a location here, and we're going to have temperature in degrees Celsius here. So basically those are the 2 variables that you're measuring. Location, which is a categorical variable, and then temperature, which is a numerical variable. It's actually continuous data. And can you see that we're going to have 5 A's? So I'm just going to go ahead and do this quite quickly. 1, 2, 3, 4, 5. And then 5 B's, just drag down. 1, 2, 3, 4, 5. And then 5 C's. So it doesn't take too long. 2, 3, 4, 5, is that right? And then 5 D's. 1, 2, 3, 4, 5. Okay. And then I'm just going to copy and paste Command C, Command V, Command C, Command V, Command C, Command V, Command C, and finally Command V. Yeah, and that seems to have done the job, right? So now we've got all the data in the form that we need it, right? I'm just going to copy this, Command C. Now I'm going to go and open Data Classroom. Now if you've got a GAPS account, everyone can have a free sign-in, and you will get a free account. And I've got a lot of data sets that I've already been using, but if you want to import data, you click this bad boy, and then paste in data from a spreadsheet is what you want. Use first row as column headings. Now did we copy the first row? Oh, we did. Look, use the first row as column headings. Click in here, paste, and now this is going to be temperature analysis at different locations. Boom. Now the first thing we're going to want to do is we are going to want to change this little setting here. So this location is a categorical variable, right? We've got 4 categories, A, B, C, D, and this is just a numeric. So it's quite simple. It's either categorical data or numeric data. And once you've got that, we're going to go click on the graph. I'm going to switch to the graph tab. Now up here we've only got the 2 variables, right? Location and column B. Oh, that's not good. Let's go ahead and change that. That was supposed to be temperature, right? That's supposed to be temperature. That was degrees Celsius. Okay. So now we've got the right variable measuring here. Location, temperature, degrees. Let's go click. Now that brings them down onto the right hand side. We are going to plot a scatter graph. Now scatter graphs are usually for numeric and numeric, but if patiently we use the location as the x-axis and the numeric as the y-axis. Isn't that nice? So you can see you've got a nice spread of data points. You can make them line up a little bit like this, which is quite nice. We can go change the appearance of the dots. Now the point size are quite thick. I'm going to make the dots a little bit smaller, like this. We can scroll down, and under the general, we can go ahead and add a title, and it'll open up a editable title box. So what would this be? Investigating temp at different locations, however you want to do it, right? And yeah, you've got title size, and that looks okay. That looks great. But now comes the magic, right? So we really want to close that up. We want the descriptive stats on here. Now, can you see we've got, this is automatically chosen a mean based, and it's plotted the mean in the center, and it's given you the standard deviation, right? And if we check on the values of this, look, the means, can you see? Now if we cross-reference and look at the standard deviations, if we cross-reference that back with our table here, there's the means and standard deviations. Well, Data Classroom sorted that out for us, right? And looks quite nice. So what can we do with this? Well, do you think there might be any outliers within the data set? This guy here, look, when we were doing location D, this guy looks quite a way away from the mean and one standard deviation above, but there is a test for outliers. Now for the test for outliers, we're going to switch, click on this boy, we're going to show the outliers, and there's a different set of rules for choosing outliers, and this is commonly used in IBDP maths outside 1.5 times AIQR. So we're going to click on that, I'm going to confirm, and look, we've drawn the box plot, and there are no dots indicated outside of this whisker. So actually, according to our definition of 1.5 times IQR, above the upper quartile, there are no outliers in any of those locations. Alright, so let's go ahead and show the dots again. And let's go back to the mean based, because I like that. So we can clearly see, can't we, that the temperatures according to that 5 reading that we did, and this is a sample of 5 readings in each location, right? So it's not a massive data set, but is there enough evidence to suggest that this location is hotter than the others? Is it possible that we just got lucky with these 5 data points, that this location just happened to be at that particular time hotter, but in general it's not? Well, this is when we run a hypothesis test, and if we click on this magic button, it will automatically give us the right test for the way we've set up the graph. So we've got categorical variable versus numerical, and you can see the x-axis, it says categorical, more than 2 values. We have 4 locations. Y-axis, numeric. Okay, so it tells us we're going to do this test. I'm going to calculate it, and look, we have a p-value. There's always a test score, right? But the test score is very different, gives us different values for different tests, okay? But what is universal for hypothesis testing is this p-value. Now this is a 3% p-value, and if we interpret the p-value, there's a strong confidence that the groups are different, alright? So basically 3% here represents the probability that we got such a difference in temperatures just by pure chance. So there's only a 3% chance that we got these differences by pure luck. Therefore, we have strong evidence to suggest that at least one of the locations is different in temperature. Now let's go back to this guy again, because you will see that it said that the groups are different. It didn't actually dig into, well, which particular groups. Now we can see, can't we, there's one location which is definitely hotter than the others, but then we can dive a bit deeper. We run this post hoc test. This is where Data Classroom now pairs up all possible locations, and we're just scrolling down here, right? And as suspected, look, it's C with A is a strong confidence that locations C and A are different. And here, another one, C with D is strong confidence that the groups are different. But notice C with B, the p-value is 9%, and this means some confidence. So if this p-value dips below 5%, then we have this strong confidence tag. Alright, so that's running a data-driven test, and for each of these you can copy all the values to your clipboard and paste it into your Google Doc. We can do a nice little screenshot of this. Just thinking about it, it'll copy it to the clipboard. Okay. So it's a really nice way of analysing data in a very, very quick way. And yeah, hope that helps.